All right, so here we've got a little ugly cubic equation here where we have the equation, but then we also have the graph. We can pull the relative min and the relative max off the graph fairly easily. So we're going to say, okay, looks like I have a min right around here. So the value, the y value is 1, and it happens at x equals 0. So I'd like for you to give me both pieces of information. And then we're looking here, this min's about 3, and it looks like it's happening at maybe 3.6 or 3.7, somewhere around there. Since we don't have calculus, we can't really find this exactly without using something like GeoGebra. So where is our function increasing? We're going to look at the graph and we're going to say, oh yeah, it's going up right there. Pretty easy, straightforward, right? So it's going, remember these are open intervals, so 0 up until about 3.7. So we'll just do a little wiggle there. Okay, so remember they're open intervals because the slope of the tangent line at the max and the min is actually horizontal. It has 0 slope. Just off of it, it'll have positive slope, which is what we're looking for with increasing. So with decreasing, we are looking to have, let's see, we're decreasing there. So from negative infinity to about 0, and from about 3.7 off to positive infinity. So we've got negative infinity to 0, and about 3.7 off to positive infinity. Okay, so this function exists everywhere. There's no vertical asymptotes. There's no holes. We'll talk about those later. It's not a square root. So all real numbers. And we can see from the graph that the range also, we're going up to positive infinity, down to negative infinity, all real numbers for the range. So let's look at graphing this in GeoGebra with my mini tabs. Okay, so we're going to type in the formula that we were given, which was negative 0.095 x cubed plus 0.494 x squared, I think it was, plus 1. We're going to check real quick. So yeah, looks about right. And so we've got our graph here. Looks a little bit nicer than the one I had, but that's okay. But so you can see, we've already clicked on this, and GeoGebra is very helpfully saying, hey, you've got an extreme here at about apparently 3.46, and for x equals about 3.46, 3.47, and a y value just under 3. And then we've got another one here at 0,1. So those are nice. If it doesn't already highlight them, you can go to Tools, Intersect, and then click, not intersect, sorry, Extremum. Yeah, we'll get the right one. And then click your graph, and it's going to find those local mins and maxes. Okay. So another one going on here, we've got a different function. We have absolute value, x plus 3 minus 7. So now we know that the absolute value function looks like a v, right? And it normally is situated at the origin. Now we're going to talk more about transformations of graphs later in this chapter, but we could graph this, really. We could graph it in GeoGebra. It might be easier for right now. So we will go turn off our function here, and we'll do our new one, absolute value, x plus 3 minus 5. So you can see that kind of shifted it left and then down. So that's about what we're looking at. So I'm going to go sketch that. So we're looking, let's make it a different color. So over about 3, down about 5. So we're looking, roughly speaking, at that. And so we can tell it's got a relative minimum, which also happens to be the absolute lowest point on the graph. And that minimum was at -5 at x equals -3. We can double check that again with our graph. There we go, -3 comma -5, which is what we said, -3, -5. Where is it increasing? It's increasing on the right side of the graph, right? So we're increasing from -3 off to infinity. We're decreasing from -infinity to 3, and remember those are open intervals. Domain, all real numbers, because there's no there's no terms in the denominator, no x's in the denominator, and no square roots. And our range, our lowest value is that minimum of -5, and then it goes on up to infinity. So there we go. All right, so we got one more where we're going to talk about absolute min and max.